Now that we have completed doing use case diagrams, use case specifications, activity diagrams, and class diagrams, the next step is to understand how can we really implement the use cases main flow, each of the use cases main flows. So in the main flow or in an activity diagram that we use to represent a main flow, we know that we have two swim lanes or two columns of responsibility. You have the actor action, actor doing something, and the system responding to that action to accomplish a particular task. So when the system is responding, we need to figure out what exactly in the system is doing something to respond to the actor's action. If the actor clicks on a menu item, if the actor inserts a card, if the actor types in this or that, the system is doing something else, right? So what in our system is helping us accomplish that task? So it has to be objects of classes that we have in our class diagram that have to communicate with one another to figure out how to accomplish the task that the system is responsible for accomplishing. So the next step of creating sequence diagrams helps us do exactly that. So what I would like to do is help you look at an example. Uh, so we have, if you go to the course website, you'd see under resources, example for tutorials. So there you'll see the description of a seminar series management system. And I have a link in the bottom here for UML diagrams. If you open that, you'll see all the diagrams that I'm about to use in this presentation. So if you'd like to pause now, go take a look at the description here, take a look at the diagrams in detail, and then come back to this presentation. I think that'd be helpful for you to follow me along. So let's go back to the presentation. So the first step is to understand what we could have already done with what we know about use case diagrams and class diagrams. So here is a simple use case diagram for the description for the requirements for that system that we just referred to. So you have the task force member as an actor. So this is about creating a seminar series. You can create a new seminar series, and then as part of that seminar series, you are scheduling new presentations. And then when the presentations are done and the series is done, you are updating outcomes. You could cancel the presentation, and obviously they have to log in, and an attendee who gets an invite can also RSVP. So you would notice that here there is a task force chair who is connected to task force member with an inheritance, and the chair is not exactly doing anything unique, right? He or she is doing everything that the parent actor is doing here. So it's probably not necessary to have this child here, but since the requirements description mentioned something about the chair, it's probably a good idea to leave it in there and then ask the client saying, are there any unique activities that the chair might use the system for, right? That's the idea. So you have that use case diagram. Now let's look at the class diagram. So we have identified a bunch of classes already based on the requirements. So following the same process that we did a few weeks back. So you have the task force member who could have account and they create a seminar, and you can go through the details of attributes and methods slowly at your own pace by looking at the example on our course website. But let's just quickly look through the class diagram. So the seminar itself could contain many presentations, and participant could actually be the one presenting, right? So it could be different types of presentations, research and teaching presentations, which are then related to different aspects of what's covered in the presentation. It could be a research presentation, could be about a journal paper, and teaching presentation could be about a particular program. And then you have the task force members sending invites to attendees who can then RSVP, right? And then you have the task force chair, who's the subclass of task force member. The same discussion about the inheritance holds true here as well. So that's the class diagram. Now, before we move on to creating a sequence diagram, we need to understand. We first need to pick a use case, right? For every use case, we need to do this, and we need to understand for that use case what are some of the user interfaces that we need that's going to help us go through the sequence. The actor is going to interact with the system typically through a user interface, right? So let's take the login use case, for example. As you have seen the use case diagram, login is identified as a separate use case. And the way we thought about this is if we are not using includes for login, which means for every other use case that needs login, there will be a precondition saying that the actor should be logged in. So let's look at how to realize the login use case. So we need two user interfaces for login. You need the first one where the user is going to type in the user ID and password and click OK. And when that's done and the validation is done, the user should be able to see a home main screen with a bunch of options that they can select moving forward, right? So here, by this, we know that there are two user interfaces, two windows or two pages or whatever you use in your development environment, two object of these user interfaces that you need to implement the sequence. So let's look at the sequence diagram. So you can learn what a sequence diagram is and how to do it by looking at this example. So for login, if I have to create a sequence diagram, this is what it will look like. So let's zoom in and see what we have. The boxes on the top here are all objects of classes that we have in our class diagram, except for one. The first box here is always an actor, because an actor is the one that triggers the execution of a use case. So the sequence diagram, you can think about a sequence diagram as a description of what happens when a use case is executed. So the task force member in this case is trying to log in, right? So they are sending a message to the login UI to validate login. What does this message mean? When the task force member is looking at the login UI, they're typing in the user ID and password, and when they hit OK, that's when the task force member is interacting with the system that requires the system to respond. So when they're typing in the user ID and password, the system is just passive. It's just waiting for something to happen, right? It's not responding every time you type a key. But the moment they finish typing in all of that and hit OK is when the system needs to do something. That's when this message one is sent from the actor to the login UI. This is the login user interface that we just saw. We saw a mock-up of that, right? So this login UI should be a class in our class diagram, and this class should have an object which is used in the sequence diagram. So when this message happens, login UI is about to send a message to what we call as a control class. Now this is a good time to talk about different types of classes in our class diagram. So far, everything that we have done in the class diagram till now are all entity classes. There are three types of classes: boundary, control, and entity. You see the notations here. This notation is used for entity class. This is for control, and the previous one is boundary. Now, what we have done so far is all entity classes, right? Entity classes reflect data. If you have attributes in a class that refer to data that you want to store permanently, that class becomes an entity class, like a student, account, a presentation, a participant, a class, a registration. All of these classes that we have done so far would likely have attributes which will carry some data which is persistent, right? Which you want to store permanently in a database for a long period of time. So if the class fits that bill, then that's an entity class. Let's look at boundary and control classes. Boundary class is a user interface class, right? So for login sequence, we just saw that in the UI mockups, we had two user interfaces. So I need to add two boundary classes in my class diagram that will be useful for the login sequence. One is the login UI, and the other one is the main home UI, right? So that's boundary. For every user interface that you need a boundary class that you need to create in the class diagram. Control is like an intermediary. It stands between the boundary and entity, sort of giving you somewhat of an independence between the two layers. So the boundary should not know anything about where to access data, how to talk to a database, and so on. And the entities should not know anything about which user interface is asking them to do what. So the control class sits in between, separating the boundary and the entity as an intermediary. So whenever the boundary wants something to be done, so in this case, the boundary, the login boundary takes in the user ID and password and sends it to the control saying, hey, this guy wants to log in. Here's the user ID and password. Can you please process this? The boundary on its own doesn't know which class to talk to get the data, to validate the login. The control knows. So the control, it's basically like the boundary outsourcing this job to the control, and not knowing what happens behind the scenes. So the control knows that if I need data to validate this login, I need to look at some entity class in the class diagram, which is the right entity class. The account class seems to know about account details. So let's get account details and ask the account class to see if we can validate the login. So it sends a message, get account details to the account class. The account class will talk to the database, retrieve the data for this particular account, and send it back to the control where the validation would happen here. And then when the validation is done, the control class sends an open message to the main UI or the home UI, which is what we saw in the UI mockup, where all the other options that the user can click on appears, right? So this should give a sense of how things work out in our sequence diagram. So let's look at the big scheme of things. So the actor types in the user ID and password and clicks OK, which becomes message one. That OK click on the login UI is this message. So every message that you have here in the sequence diagram becomes a method in the destination object. So validate login is now going to be a method in the login UI class. And the login UI is telling the control, hey, can you please validate this login? I don't know what to do. You need to figure out by talking to other classes how to validate the login. And this validate login becomes a method in the control class. And then the control class cannot retrieve data on its own. It needs to just figure out which classes can get its data that it needs and then process that data. So it's asking the account class saying, hey, can you get me the account details so I can validate the login? So the account class, so this get account details becomes a method in the account class. So somebody has to write code in these methods, right? These are methods in classes. So when a programmer writes code into the get account details method in the account class, they'll write code in such a way that it accesses the database, retrieves the right record from the account table in the database, and then sends it back. So these bars that you see here are control, our focus of control. So which method has control when? So this method has currently control when the account class is using the get account details method to retrieve the account data. And then when it's done, something could be returned to the login control. It does some processing and then it does the next thing. So now the login control, after validating, assuming that everything works out okay, sends a message to the boundary class, the main UI, saying that open up now. The user wants to click on some options for doing some operations on you. So that's the story of the login sequence. Um, we can also look at another example. Before that, let's look at the class diagram update. So instead of showing the whole class diagram, I just took a snippet of it away so that we see the classes that we need for the login sequence. Right? We have the two boundary classes, login UI and main UI. We have the login control, and we have the account class. And we have drawn these relationships based on the direction in which these classes are talking to one another in the sequence diagram. Right? If you go back, you will see that login UI is the one that's sending the message to control, control is sending the message to account, and then control is also sending a message to main UI, right? So early on, a few weeks back, we talked about navigability. This is what it means. Which class is able to send a message to which other class? Based on that, we put these arrows in, and these are simple associations. So let's move on to the next example, where if you're trying to schedule a new presentation, what happens? So the precondition would be that the user should be logged in. So they're logged in and they're looking at the screen. So they could click on this button, create new presentation, which might take them to this presentation UI, right, where they put in the topic, the date, all the details that they need for the presentation, and click submit. What happens then when they do that, right? So we now know that there are these two user interfaces that we need in this sequence that we need to create as boundary classes in our class diagram. So let's look at the sequence diagram. Obviously, this is not readable, so I'm going to zoom in and show you the details. So the task force member is the one that's trying to schedule the new presentation. So they're interacting with the main UI first, right? In the main UI, somebody had to go and click create new presentation. That's this message one. And the main UI then opens the presentation UI, which was the second UI that we saw in the UI markup, where you need to fill in all the presentation details, right? So after this is done, the next step is the task force member submits all the presentation details into the presentation UI. And then clicks OK or submit, right? When that's done, the presentation UI needs to pass this to the control. So the control is, as I said, is the intermediary, right? So it takes all of that data and then it sends it to the presentation class. In this case, we take a particular scenario. So sequence diagrams typically show sort of a best case scenario. When everything works well, for a particular example, how would the sequence look like? So we are picking an example that here we are scheduling a new research presentation. So we use the research presentation object, which if you remember from the class diagram, is a subclass of the presentation class. So here we are asking this class to create a new presentation. So when somebody writes code for this method in this class, they will have to access the database in that piece of code, access the table where research presentations are created, and create a new record there for this research presentation, right? So that's the story of scheduling a new presentation. So as you can see, sequence diagrams could get complicated pretty quickly. There are three key takeaways that I want you to understand. We can look at those takeaways by looking at the last sequence diagram. As I told you, each of these messages become methods in the destination objects. So this one, message one here, schedule new presentation, becomes a method in the main UI. This open becomes a method in the presentation UI. create new presentation becomes a method in this control and so on. So any message here becomes a method. And when you do this in IBM Rational Software Architect, when you create a sequence diagram, when you create these messages in a sequence diagram, it automatically updates your class diagram with the right methods to be added. That's kind of an advantage of using IBM RSA over Lucidchart. In Lucidchart, you'll have to do some manual updates, whereas IBM RSA does its best to make sure it keeps the different diagrams consistent with one another. Um, the other important thing here is when two objects are talking to one another here. So here, for example, the main UI and the presentation UI are related, right? So that means that the two classes of which these are objects should be related somehow in the class type. So we need to go back to the class diagram and make sure these two classes are related to one another. The same with this message. Are these two classes related to one another in the class diagram? We need to go back and check. And the same with these two and so on. So for that, a sequence diagram might not be exactly that helpful, because in this case it's a simple sequence diagram, right? What if I have a sequence diagram with like 35 messages? Comparing every pair of objects to see if they're related to one another in the class diagram is going to be a little difficult. So we can then generate what's called as a communication diagram to do that, where it shows coupling between objects, which will help us create relationships between classes in the class diagram. So that's what we have for sequence diagrams. So you can always go back to the example, as I said, to the tutorial page on the website, and look at the various diagrams that I have there and revisit this video again.